This is section 8 of chapter 7. This is the last section in chapter 7. The objective is to be able to write and use recursive formulas for geometric sequences. What is a geometric sequence? It is where the ratio of any term to its preceding term is a constant value. So what we're talking about is comparing any term to the term that comes before it in some kind of a sequence, and where the ratio from one to another stays the same. So a lot of times when you think sequences, you think something like this: 2, 5, 8, 11, 14. And where the difference is the same. You add 3 to go from 2 to 5, you add 3 to go from 5 to 8, you add 3 to go from 8 to 11, and you add 3 to go from 11 to 14. So that's an arithmetic sequence where you add, or you can subtract the same amount each time. A geometric is something different. So this is not an example of a geometric. Okay? In a geometric sequence, you start at a value, and then you have a common ratio, and that ratio we're going to call R. So A is our starting value, R is the common ratio, and the sequence takes the form of this. So you have just A. The next time it's A times that ratio to the first. They don't show it, but this is to the first. The next time it's A to R, that ratio squared. Then it's A times that ratio to the third, and so on. And we can show this in two different ways. We can show it recursively or explicitly. So the recursive definition for a sequence has two parts: the initial, which is where it starts, and then the recursive formula. And you need both of these parts in order to define the sequence. In explicit, you don't. What you need is you basically, you do need both those parts, but you're able to just start anywhere. You need the initial, and then you would be able to like find the 20th value in that sequence. Where here, with recursive, you need the 19th in order to find the 20th, and you need the 20th in order to find the 21st. So we'll show you those in some examples. First off, which of the following are geometric sequences? So are these geometric sequences, yes or no? So what we're looking for is, what happens? How do you go from 20 to 200? Well, you could say you add 180, right? You're right. How do you go from 200 to 2,000? You add 1,800. Here you add 18,000. Are those the same each time? And the answer is no. So since those are not the same, okay, it's not a geometric, right? Adding the same thing, even if it was the same, adding the same thing doesn't make it geometric. What else could you do? Well, you could multiply them. First one, you can multiply by 10, multiply by 10 again, multiply by 10 again, multiply by 10 again. So remember, geometric sequences is when we're looking for something being multiplied. So if the only way you can find the sequence is adding the same number, like this next one, that doesn't work. So here, so is this a geometric sequence? Yes, it is. The common ratio in that one would be 10. So R would be 10. Here, we're adding 10, adding 2 each time, adding 2, adding 2. So yes, it's constant, but we're not multiplying. And so therefore, that is not a geometric sequence. Here, is there anything you can multiply or divide by to go from 5 to negative 5? You can multiply by negative 1. To go back from negative 5 to 5, you could multiply by negative 1 again. And again, multiply by negative 1 and multiply by negative 1. And so our ratio, our common ratio, is negative 1. And therefore, yes, it is a geometric sequence. Oops, sorry about that. Okay. We're going to skip that anyway. So, any geometric sequence can be written with both an explicit and a recursive. All right, so we're going to work on that. So find the recursive and the explicit formulas for these sequences. So what we're looking for, first off, is the common ratio, okay? So if we were to write it recursively, you go back in your notes, we need two things. We need A1 and we need formula, which is this. Okay, so we need A1 and we need our formula. A1 is your initials, so we'll just call it A. Okay. For explicit, we need, for A sub n, we need our first one times our ratio to the n minus 1. Okay? So let's see if we can figure out how do we go from 7 to 21. And the answer is we multiply by 3. Does that same thing work going from 21 to 63? Yes, it does. And from 63 to 189? Yes, it does. So our ratio is 3, our common ratio, and our first term is 7. So is that all the information that we need in order to write them recursively and explicit? Yes, it is. So if we go recursively, A sub 1 is going to be 7. And therefore, our formula would be like this. A sub n equals A sub n minus 1 times 3. Remember, you have to have both those parts. Explicitly, it kind of combines those. So we have A sub n equals our first term, which is 7, times 3 to the n minus 1. And that right there is our explicit formula. So again, the biggest thing is finding out what the common ratio is and finding out what the initial value is. And then forming the recursive and the explicit formula. Find the recursive and explicit formulas for each of the following. So what do we multiply by to go from 2 to 4? We multiply by 2. To go from 4 to 8, multiply by 2. 8 to 16, multiply by 2. So our ratio is 2. And our first value, our initial value, is 2 here. So our ratio is 2 and our initial value is 2. So our recursive, we would have to state A sub 1 equals 2. And A sub n equals A sub n minus 1 times 2. So that's recursive. And explicit would be A sub n equals A sub 1, which is 2, times 2 to the n minus 1. Here, how do we go from 40 to 20 and from 20 to 10 and from 10 to 5? What do we multiply to do that? We have to multiply each one by 1/2. So therefore, our common ratio is 1/2. And you can have fractions. Now you might be saying, well, you just divide 40 by 2 to get 20 and divide 20 by 2 to get 10, and you're right. But you multiply by 1/2, so you have to have that in mind. And our initial value is 40. So recursively speaking, A sub 1 starts at 40, and A sub n equals A sub n minus 1 times 1/2. Explicitly, A sub n equals 40 times 1/2 to the n minus 1. So remember, recursive only works if you know the value before it Explicit can work at any point. Two managers at a clothing store created sequences to show the original price and the markdown price of an item. Write a recursive formula and an explicit formula for each sequence. All right, so manager 1. So we got to find out what are they, what's the ratio here? What are they marking it down by each time? Now before it was kind of easy to find, right? We just go, and what you can do is you take the one before it, so you go 4 divided by 2 equals 2, 8 divided by 4 equals 2. You just divide two terms in a row. You can do the same here. So you always take the one before it, the one further down the list, and divide it by the one previous. So we take 51 divided by 60, and when we do that, we get 0.85. And if we take 4335 divided by 51, we get the same thing, 0.85. So there's our common ratio, R, 0.85. Now, I want the sixth item, the sixth markdown in the line of markdowns. And so yes, I could find the fourth and fifth and sixth, but I want the explicit formula here because that'll help me find the sixth much easier. So that's A sub n equals the initial, which is 60, times 0.85 to the n minus 1. And now when I plug 6 in, I have A sub n equals 60 times 0.85 times 6 to the minus 1 to the fifth. Sorry, where I messed up on the sixth markdown. So the sixth markdown will actually be the seventh price. So what I messed up on is I should have been putting 7 minus 1 here, which is 6. That would be six markdowns, the seventh item. And when we do that, when we plug that in our calculator, you get a price of $22.63. Okay? Here, same thing. So we have to take 52 divided by 60. And if we do that, we get .867. And if we take 44 divided by 52, we get 0.846. And that's not the same. So if that's not the same, what do we do then? Well, one, we know that it's not what? We know that it's not geometric. So we have to go back and we have to figure out, okay, if it's not geometric, what is it? Well, it could be an arithmetic one, right? So how do we find that? Well, we find that by taking 60 minus 52. We get 8. We try 52 minus 44. We also get 8. So what you're actually seeing here is, to go from 60 to 52, we subtracted 8. From 52 to 44, we subtracted 8. So we're actually, we're finding out that we're in an arithmetic, and so our common ratio is -8. Okay? So we're going to erase this, and we're going to come up with what would our explicit formula be for an arithmetic? And I know that's a few chapters ago, but it's A sub n. Our common ratio, which is R, is -8. So that's -8 right here, times n minus 1, plus our initial value, which is 60. And if we want our seventh item, which would be the sixth markdown, we plug in 7 right there. 7 minus 1 is 6. minus 8 times 6 is negative 48. Negative 48 plus 60 is 12. And therefore, in this case, our sixth markdown would take us, sorry about that, our sixth markdown would take us to $12. And over here would take us to $22.63. And all right, and that's section 8 video.